Welcome back to the Dr. Liu VCE Physics channel. In this video, we'll go through the 2025 NHT Physics exam, focusing on questions related to Newtonian mechanics. My explanations may not be perfect, so if any teachers, parents, or students notice any errors, please feel free to offer your feedback. The normal force acting on a skier on a perfectly smooth, frictionless slope is always perpendicular to the surface of the slope. This is because, by definition, the normal force is always perpendicular to the surface of contact. A tennis ball falls vertically from a height h onto a solid wooden floor, and then bounces back up to a height of 0.6 h. The ball's contact time with the floor is very brief, during which the ball momentarily comes to rest. To achieve this halt and rebound, the normal force exerted by the floor must be greater than the gravitational force to reverse the ball's momentum. Compressing a spring stores elastic potential energy within it. The magnitude of this energy is mathematically represented by the area under the force versus displacement graph, which forms a triangle for an ideal spring. A horizontal force of 64 N is applied to two masses, A and B, as shown in figure 1. A and B accelerate from rest at 4.0 meters per second square. Assume the surface is frictionless and that air resistance is negligible. We will define the two objects, A and B, as a single system, where the total mass is, assuming a frictionless surface and negligible air resistance, the net external force acting on the system is 64 N. By applying Newton's second law, we can establish the equation of motion to solve for the mass of B. Both objects, A and B, share the same acceleration. Considering B in isolation, the only external force acting on it is the force exerted by A, as the surface is frictionless and air resistance is negligible. By applying Newton's second law to object B, we can establish the dynamic equation and solve for the magnitude of forces exerted on B by A. The magnitude of the force exerted on object B by object A is equal to the magnitude of the force exerted on object A by object B, as these two forces constitute an action-reaction pair, as defined by Newton's third law of motion. Injury severity is directly related to the applied force. Since impulse equals the change in momentum, a safety measure that increases the contact time during a collision effectively decreases the average force experienced, thereby reducing potential injury. Anna, with a mass m of 40.0 kilograms, steps off a diving board located at an initial height, h, of 2.50 m above the water. Assuming negligible air resistance, all of her initial gravitational potential energy will be converted into kinetic energy just as she hits the water. Based on the conservation of energy, with air resistance ignored, the kinetic energy gained is equal to the initial gravitational potential energy lost. We will substitute this known kinetic energy value into the relevant formula to calculate Anna's final speed upon hitting the water. Doubling the impact speed results in 4 times the kinetic energy, since kinetic energy is proportional to the speed squared. Consequently, the initial gravitational potential energy, and, therefore, the starting height must also be quadrupled. This section contributes 16 marks, 13.3% of the total 120 score, and examines fundamental concepts in Newtonian mechanics. Multiple choice questions, 3 marks. Question 1, normal force direction. The normal force always acts in a direction perpendicular to the contact surface. Question 2, impact forces, impulse. For an object to rebound from a surface, the instantaneous normal force exerted by the surface must be greater than the opposing gravitational force. Question 5. Elastic potential energy. The elastic potential energy stored in a spring can be calculated as the area under the force displacement graph, work done. Short answer questions, 13 marks. Question 1. Systems and Newton's laws. When two objects move together, they share the same acceleration. The forces they exert on each other are action-reaction pairs with equal magnitude, as defined by Newton's third law. Question 2. Impulse-momentum theorem. The impulse-momentum theorem explains that for a fixed change in momentum, extending the time of contact will effectively decrease the average net force. Question 3. Conservation of mechanical energy. Assuming air resistance is negligible, the system's gravitational potential energy is entirely converted into kinetic energy, illustrating the conservation of mechanical energy. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.